Alright, episode 16, let's go. The last video was very long, I'm sorry about that, there was loads of information in it. So, before we get into the topic of this video, which is classes, let's just revise over methods in general. At their simplest, methods have two parts. First comes the return type. That's what type of data the method gives back to the caller. We can write void there if our method doesn't give back anything. Then comes the parameters. This is what the method takes in. You can have as many of these as you want. You give them names, and you can use those names to access them exactly as if they're variables. If we imagine we have some code like this, what's essentially happening here is when we get to this line, we're setting our parameter x to the string hello world, and we're setting the parameter y to the number 10. Then it runs the code in the method and we can just write x and y in there to use them inside the method. We also looked at escape sequences, if you remember that. How you can insert special characters like a new line character into strings, and techniques we can use when using methods, like using return in a clever way and recursive programming, which is having a method call itself. But don't worry if you didn't fully get that bit. Alright, in the next video, we're going to take a bit of a break and do some visual things, like making our own windows with buttons on them, and things like that. But until then, there's one more topic I want to cover, and that's classes. Classes are one of the most fundamental parts of object-oriented programming. C# is an object-oriented programming language, which is the idea that you have these objects, classes, and that you can manipulate and do things with them. Let's roll the intro. We've used classes a lot in C#, you just haven't noticed it. What might come to mind is the class console, where we can do console.writeLine, or the class math.squareRoot. But I want you to forget about these for now, because these are things called static classes, or at least the things we've used inside them are static. I'll cover what static is later on, but just forget about them at the moment, because they act differently from what I'm going to show you. Alright, with that out of the way, let's actually look at what a class is. A class is basically a way to make our own data type. It's a reference type, and this data type is made up of smaller pieces. A great example is a person. Think of what information we could have about a person. Well, they can have a name, an age, a birthday, hobbies, and so many more. They have all of these smaller parts of them. What we could do in C# is we could make a class called person, and inside this person we can put in variables like a name or an age. These are the smaller things that a person is made up of, the smaller bits of information about one person. So let's do that. Let's hop into Visual Studio and make a class. When we make classes, we generally put them in different files so they're all separate. However, you can put multiple classes all in one file. If you ever do put multiple classes in the same file, it's just like with the methods. You shouldn't make classes inside classes. You should put the classes next to each other like this, not inside each other. However, to keep things more organized, we generally put one class per file. So we already have this program class in this file. So we're going to add another file to our project. To do this, we need to go into the Solution Explorer. If you don't have it, you can find it just by going up to View and Solution Explorer. Now that we're here, we're going to right click on our project, which is this thing here, and choose Add and choose Class. What this is going to do is it's going to make a file and automatically put a class in there for us. So it's asking us for a name, for something to call this class. We're going to call it person. And here we are. We have a person class. If we want to rename the class, we can technically just change the name of the class right here. You'll notice that this is how we make a class. We write class followed by the name of the class. So if I wanted to call this class animal instead, I could just type animal here. Now keep in mind that this file is still called person, which is a bit messy. It's a bit messy to be making a class called animal inside a file called person. So we'd also have to go into the Solution Explorer, right click on our file here, and choose rename, and give it a different name. I talked about this in episode 5, but up here each file opens as a different tab, and we can just close them. And to open them back up again, we just go into our Solution Explorer here, and double click on whichever file we want to open. Anyway, let's keep it simple. Let's just say that every person has a name and an age. So within this class, we're going to add a name and an age. The name is going to be a string, of course, and we make it just like normal variables. So we write string followed by name. And we'll also add the age, which will be an integer, of course. And there we go. Now, each person has a name and an age inside them. And we'll see in a minute that we can use this person class exactly like a normal data type. Now, there is one problem with this. If you remember back to scoping, these variables can only be accessed from inside the class. And sometimes we want that, but for this example, that's going to get in the way, as we'll see later. So a special thing that only exists on variables straight inside classes like this is something called public. And this means that you can access these variables from outside the class. I'll cover public in more detail later though, so don't worry about it too much. Just put public on anything you put inside the class here. Okay, now let's get to using this class. So what we can do now is we can use person as if it's a data type. But first, let's look at something called instances. So person is a class. It's essentially a representation, a template if you like, of what each person would have, a name and an age. But this isn't a person. This just describes what a person is like. But to actually do stuff with this person class, we have to make something called an instance. And that's essentially then making one person. Think about this. There is more than one person in the world, so each person would be an instance of this class. So let's imagine we have one person with the age of 40, whose name is John, and someone with the age of 26, whose name is Alex. Yes, I'm very creative. Those are two different people. So we would have two instances of our person class. So essentially a class is almost like an outline of what to have inside a person. It doesn't actually have any data inside those variables until you make an instance, and then each instance can have different data in the variables. So let's use this class. We can use it exactly as if it's a data type. So if we want to make a variable that contains a person, we just write the name of our class as the type, and the name of the variable. Now if you remember, this is a reference type, meaning this is null. We need to actually make an instance of this class and set this variable to that instance of this person class. To do that, all we do is we set the variable to a new person, followed by brackets. This is how we make a new instance of our class. We write new, followed by the name of the class, and empty brackets. So now we have an instance of our person class stored in this variable. What this means is this one variable now has a name and an age inside it. So what we can do now is we can write the name of the variable followed by a dot. And you'll notice that we can access the name and age that's stored inside this variable, this instance of the class. And we can set them, we can get what they're set to, and so on. And if I set the variable to a new person class again, then this is essentially starting fresh. We're making a new instance of the person class and replacing the instance that we had in the variable before with the new instance. And C# will automatically delete the old instance from the RAM since it's not being used anymore. In a lower level language, you'd have to do that yourself, but C# does this for you. Or, how about we make an array of these people? So it will be a person array, and we give it a name. I'll just write ARR, short for array, and we do all of this as usual. Now, you have got to remember, person is a reference type. Classes are reference types. So all of these items inside the array are going to be null. They aren't actually set to an instance of person. But what we can do is just loop through each item and set that item in the array to a new instance of person. So here's what's happening here. We're making an array. In fact, look at this. We're making a new instance of an array. An array is a data type, and we're making a new array. We're making an instance of a person array with 5 items in it. And yes, remember, when we're making the array, this number starts at 1, not 0, like when we're trying to do something to one of the items. A good way of remembering that is to just remember that you can have arrays with 0 items in them. So that's why here it starts at 1. It's to allow you to make an array with 0 items. Anyway, we've just got an array with 5 null items in it because, remember, reference type starts at null. And if we try to access something inside one of the null items, like we try to get the second person's name, for example, then this will give us a null reference exception because the second person inside the array is null and we're trying to access the name inside them. So, after we've made our person array with those 5 null items, we then set each of the persons inside this array to a new instance of person, so they aren't null anymore. So by the end of this, we'll now have 5 people inside this array who each have a name and an age. And if we decide that we want to add more things to a person, like is alive, then no problem, we'll just add another thing to the person class, and we can now remember whether each person is alive or not. So to take this program a bit further, how about inside this for loop, in addition to setting the item to a new instance, right after we make the item a new instance, we're also going to get the user to input a name and an age. And we're just going to put the result of those straight into the variables inside the person. Let's debug this and see what's going on. So first, we make our array. Now, if we look at the items inside our array after this line, they're all just null. We haven't set any of them yet, and classes are reference types, as I've said. So the next thing we do is we go through each item in the array, so each person in the array, and we put a new instance of person into it. So we're on the first item right now. It's just null, until we set it to a new person. Now we have an actual instance, and you'll notice the debugger lets us look at all the things inside this class just by clicking on this arrow. So we can see that the name in here is null, because we haven't set it to anything yet, and strings are reference types, so that's why. The age is 0 because again we haven't set it to anything, and integers are value types, so they can't be null, so that's why it starts off as 0. And the boolean is alive too. Once again, that started off as false because it's a value type. Remember, numbers and booleans are value types. Almost everything else, including our classes, are reference types. So what we then do is we set that name inside this person, the first person, to whatever we enter. So, as I think you will get, we take what the read line returns and put it into the name variable inside the first person in the array, since I is 0 at the moment. And we do the same for the age. Now, we haven't touched is alive, so it's just going to stay as false, but maybe we should set it to true in this loop. Great, that's classes, and that's the last big topic until we start getting into the real advanced stuff. In case you haven't noticed from the thumbnail's colour, we're in the intermediate section now. We've pretty much done about half of the entire programming language by this point. And classes are such a great thing, because you can really organise and structure lots of data neatly with them. Let's do a more complicated example, and now this shows how you can create some very detailed classes. We could have a class that represents a school. Inside here we'll have a name, the name of the school, and how about we use our person class here to represent the students. So inside each school we'll have an array, or in fact just to make it easier, let's use a list here. So a list of people using our person class from earlier. So now each school will have a list of people in it, and those people will be the students. Cool. By the way, as you should remember from earlier, you should generally use arrays as much as you can, and only use lists when you really don't know exactly how many items will be in there, because lists are slower in speed than arrays. And how about we make a list of all the classrooms in the school? I think I'm going to make another class called Classroom that says what information we have about each classroom. So each classroom will have a name. That's what the room is called. And, I don't know, capacity, how many people you could fit in there. This is all just to demonstrate how classes work and how you can use them to store lots of data. Now, our school can have a list of classrooms, and each of those classrooms in this list will have a name and a capacity on them. So let's use this class. We'll just have one school. Now, we have to be careful, because these lists inside this class are going to start off as null, the list of students and list of classrooms. That means that anytime we try to use one of these lists, we're going to get a null reference exception, and here C# doesn't stop us from doing this. There's no failsafe for things inside classes. So if we're going to use these two lists, we'll have to manually go in and initialize them too, after we also make the school. So we'll set the students list to a new list, a new instance of list, you see. And we'll do the same for the classroom list. But of course it has classrooms in it, not people. Alright, now, let's add a student to our school. There are lots of ways we could do this. One way is we take the students list and add to it. So we're adding whatever we put into these brackets to the list. We add a new person. So it makes a new instance of person, a new person, and then puts that new person into the list. Then, to change the name and age of this person, we just access this student in the list. Now in this case, since the list was of course empty before and we just added one person to it, the person we just added will be the very first item. So we could access that person by getting the first person in the list, then changing their name. And then we also have to do the same, but this time changing their age. So let's slow down a bit here and look at what's going on here. First, we make a new school. Inside the school, we have a name and a list of students and classrooms. So each person inside this students list is a student in the school, and each classroom inside this classrooms list is, well, a classroom. But these start off as null because lists are reference types. So if we want to use them, we need to initialize them to new lists, which is what we do right here after we made our school. We haven't bothered to set the name of the school, but whatever. Then we add a person to the students list. So we make a new instance of person and add that instance to the end of the list. But we haven't set anything about that person. They don't have a name or an age. Those are just whatever they start off with, which is null and 0, of course. Now, since we only have one person inside the list, the one we just added, the first item must be that person we just added. So we access that person we just added to the list and change their name and age. Now another way we could do this is to first make the student inside a variable here, set their name and age, and then add that student to the list. So first we make the student, set the name and age on this student variable, and then take that student and add that student we just made to the list. Both are perfectly fine options, although this looks neater. By the way, just a bonus question. If, even after I've added it to the list, I change something about my student variable, like changing the name, then will the one in my list have its name changed too? The answer is yes. Remember, classes are reference types, and that means that both what's in the list and this variable refer to the same instance of person. However, as you should remember, if I set the student variable, or set the item in the list to a new instance, then only that variable or item in the list will change to the new instance, because setting it is changing just that one to refer to a different new instance. And then they no longer refer to the same thing. If you remember, that's how reference types work. Alright, so we've looked at adding variables, or as they're actually called, fields. That's what you call them when they're inside a class. But what about methods? So let's add a method to our school. Now, just like the variables, even the method needs to be public, otherwise scoping will stop us from being able to call the method from outside the class. Once again, we'll properly cover public in a future video. Now here, we don't want to write static on it. It's only when we're putting stuff into the person class that we want it static. Once again, it will all make sense soon, but basically, only put static on stuff when it's inside the person class, nowhere else. So this method will find a student based on their name and give back that student. So this class will return a person. It will return that student that we were looking for. We'll call it find student by name, and we'll make it take in a string. Now we're going to use our linear searching algorithm from the last video. So we have a for loop that goes through each student. And remember, because this is a list, it's got a count on it instead of a length. Now, notice how I can access the students list just by saying its name. I don't have to do something dot something else, because this method is inside this class. I can just access all the variables that are inside whatever instance we called this method for. All of these variables easily just by saying their name. Same goes if we want to call another method we add to this class. We can just say the name of the method and it will just work and run the correct one. Then we increment I on each iteration, and inside the loop we put in an if statement. And what this if statement does is it looks at the current student, so the student we're looking at now at this position in the list. Then we look at that student's name and check if the name equals the name we're looking for. And if it does, then we can just return that student. But what if we didn't find a match? Well, in this case there are a lot of different ways of doing this. But one way that's extremely common, and it's not necessarily the best way, but I still tend to write code like this to be honest, is to return null. Then the person who's calling our method can check if our method gave back null, and if it did give back null, then it could show a message saying that student doesn't exist, or something along those lines. You could also do this with an out boolean, however, that says whether it found the item or not, which may be cleaner. Or, if our method was giving back what index, what position in the list this person was in, so basically if it gave back I instead of the actual student, we could make it return -1 to represent that it didn't find a match. And as you'll find later on in your time with C#, many of the built-in C# methods do this. They return -1 if they didn't find a match, and well, any other number if they did find a match, and that number is what index that item is at. And now we could use this method easily. All we would do is look at our instance, do a dot again, and inside there we have our method. So we just type that in and put in the brackets what student we want to search for. Let's put that into a variable called foundStudent. And if it gives us null, so if foundStudent gets set to null by this, we'll say failed to find student. And if we run it, this will find the Alex student we added to the list earlier on in the code. Of course, in this case, we could have just accessed our student variable. But if we imagine these two happened at two completely different times in two completely different places. So let's quickly debug this. So here we call our findStudentByName method, and as I step into, you'll notice that it goes into this method. Now, because we ran the method on the instance we have inside the school variable, anytime the code inside the method goes to access one of these variables, it will be accessing the variable in the instance. You'll get the hang of it over time, don't worry too much about it. And then we do our linear search. We go through each student, which there's only one, and check if their name matches, which it does. So it returns this student. And there we go, we have our result. It's the student with the name Alex and the age. Great. Alright, the final topic of the video is constructors then. This is all good, but it's really annoying if every single time we make an instance of school, we have to also initialize the list inside it too. Like we're doing here. What if we could make it so it runs some code every time we create an instance of the class? So what if we could make it initialize these two lists whenever we run this new here? And that's where constructors come in. A constructor is a special method that runs when we make or construct a new instance of a class. Defining the constructor is a bit odd, and it's got its own syntax that no other method has. It is quite odd. First, we'll write public because it won't work otherwise. But then, to make a constructor, all we do is write the name of the class, then brackets and curly braces. And yes, this needs to exactly match the name of the class. So notice how there's no return type. Or you could say there's no name and it's just a return type. Whatever way you want to look at it, this is how you declare constructors. And now, any code we put in here will run when we make a new instance, when we run new on our school. So what we wanted to do was when we make an instance of our school class, it automatically initializes these lists for us. So let's do that. Let's move this list initialization into the constructor. And remember, just like our method here, because this constructor is inside the class, we can just access the fields variables inside the class just by writing their names. Nothing more. So yes, I know this is a little strange how we make constructors, but this is how you do it. Oh, and of course, you have to make the constructors in the class you want to add the constructor to. I couldn't just put this constructor off in the program class. You have to make the constructor in the class you want to add the constructor to, just like the methods and the fields. So if we debug this, when we run this new here to make a new instance, you'll notice that it runs our constructor and sets the lists. Awesome. Now, the constructor doesn't have to have no parameters. You could add a class that has a constructor with parameters. And if it's quite a small class like our person, then it's quite a good idea. Because we can really shorten down our code from all of this to just one line if we have a constructor that sets these variables for us. Let me show you what I mean. So inside our person, we're going to add a constructor. So we write public, the name of the class, and brackets. And what we'll do is make this constructor take in a name, that's the first parameter, an age, that's the second parameter, and whether they're alive or not, that's the third parameter. Now we're going to give these lowercase names, which is different from these which have uppercase names. So we're going to set this one with the capital N to our parameter with the little n. So it's taking what we have in our parameter and putting it into the variable in the class. Then we're also going to do this for the age and whether they're alive. Now, if we go back to our program class, you'll notice that we actually have an error here where we're trying to make a person class. And that's because what's happened is when we made this constructor, this is the only constructor in the class, the only way of making an instance of the class. So you have to provide these parameters when making a new instance. So in order to provide the data to these parameters, all we do is just put it in these brackets. So this person's name will be Alex, this person's age will be 26, and they are alive, so we'll put true here. This here matches up to our constructor here. It's just like this is a method and we're calling it. And what's happened is this constructor that we made has set the name to this, and age to this, and is alive to this for us. So we don't need to be manually changing them like this anymore. And if we don't need to be doing that, then we don't need to be putting them into this variable either. We can just put this straight into the list. So let's debug this one final time and see what's happening here. So first, we make our school, and we added a constructor to our school. So what happens is it runs that constructor, and that initializes the two lists in the school. Then, there's a lot going on the next line, but if you break it down, it's quite simple. So the first thing that happens is we make a new instance of our person class, but using our constructor with parameters. Remember, we made this constructor that takes in the name as the first parameter, the age as the second parameter, and whether the person is alive as the third parameter. Then here in our main, we say that the name parameter will be Alex. This will be the age, and this will be whether they're alive. So that's the first thing that happens. We run the constructor with all of those in there. And what happens then is our constructor sets each variable in this new instance we're making to the correct things. And then when we exit this constructor, we've now made a new instance of our class, and it takes that instance we just made and adds it to the list. So, programming tasks. There are none on the website, because your task for this video is a bit more creative. Your task is to try and think of things in real life and try and make classes that represent them, and maybe even think about what methods you could put on them. For example, if you had an animal, maybe that animal could eat or walk. If you add methods, obviously don't worry about putting any proper code in them. It's just about coming up with classes and laying them out. And I think this is quite a fun task in my opinion, and it's a good practice of making classes. Then, once you've made your classes, try adding some useful constructors. Think carefully when adding constructors about which variables are most important inside each class. Adding a constructor with 10 parameters, well, making any methods with 10 parameters is pretty messy and bad. So in that case, just make a constructor that sets what you think are the most important fields, and maybe set all of the other fields to some kind of default value. Like, for this person, I could make this just take in a name and an age, and yes, I'll change the code in program to match also, and then just assume that this person is alive. And then only if someone specifically goes in and sets this to false is this person represented as being dead. So if you have big classes, think about what to put as the parameters on the constructors. And if you have any lists or arrays in your classes, it's also good to initialize those in the constructor too. Then the final part of the task is to write something in main that lets you input all of this data and puts it into the classes. So for example, assuming I added a constructor to the classroom class too, this is how it could look when inputting all the information about a school that we had. The name, the students, and classrooms. You can pause for a moment and think about what this code would do. The classrooms and students code is pretty much the same. And the next video is going to be quite fun too, because we're going to first do a bit of revision since we're halfway through the intermediate part, but then we're going to do something different, and I'm going to introduce you to WinForms, which lets you make windows with buttons on them, so hopefully it will be refreshing to do something different than just a console for once. Anyway, until then, I'll see you all next time. Bye.